We're going to discuss about game theory. So this is a very interesting subject, and in game theory, what we do is we study games. So I have to put it in a simple way. So what happens in a game? In a game, you have players, you have rules, and you have outcomes, right? And all the players have certain moves. They can make a move like chess, right? I can make some moves, and for every move, I can get an outcome, right? And I want a desirable outcome where I can win the game. There are moves, there are outcomes, there are rules, and there are players. So in game theory, what we do is we study these four people and we understand how can the players play the game better so that they can win the game. That is game theory. There's something called reverse game theory, which is more like how do we design the game so that the players play it the way we want them to play it. If you're a teacher or if you're the government, you want to do policy, reverse game theory can become, useful. Now, before moving into some concepts of game theory, I just want to just bring in some interesting tactics from games, right? Forget game theory. I'll just bring in some, tactics from games. And so the first thing which I put in the message is this story of Alex Hales. So there was this player called Alex Hales who was playing for, Sunrisers Hyderabad. So Alex Hales was playing for, Sunrisers Hyderabad, and he was playing against a certain bowler called Avesh Khan. Okay. And this Avesh Khan at that point was an under-19 bowler, just came out of under-19, and Alex Hales wanted to fool Avesh Khan. So what he did was, when Alex Hales was batting, he moved to the offside. He moved this way. So when he moves this way, what is the impression that the bowler is going to get? Where is Avesh Khan going to hit the ball?
Right.
This way, right? To the
Leg side.
leg side.
Yeah.
So Avesh Khan gave an impression that, hey, I'm going to move here and I'm going to hit on the leg side. Now, why do you think Avesh Khan is doing that? What does it do to, I mean, if Alex Hales does this, what does it do to Avesh Khan?
He's just trying to fool it.
So if you're a bowler and you see the batsman is moving to the right and the batsman is hinting that he's going to hit towards the leg side, what you bowl it more and more to the offside, right? So that because if it comes onto the body, the guy is going to get it, and Alex Hales is already 6 feet 5 inches tall. So with that height and with that power, he's going to deposit it in the stands very safely. So let me state the game again. So it's like Alex Hales is batting, he's a player, and he moves to the right and he gives a suggestion, he gives a hint that maybe he's going to, hit it on the leg side. And what does Avesh Khan do? Avesh Khan, bowls the ball on the offside because he doesn't want the ball to, reach Alex Hales. Because if it reaches Alex Hales, he's going to hit it out of the ground. So, but then what does Alex Hales do in the last moment? He went here, right? Then again, he moves back and he hits it this way. Did you understand the strategy? He moves here, makes the bowler ball the ball on the offside, moves back, and then hits it on the offside, and that's a 6. So that's a double bluff, right? You bluff and you make that fellow play to that bluff, and then you bluff again. You break your bluff. So now similarly, in the same year of the tournament, one other Sunrisers bowler called Siddharth Kaul did a double bluff against this batsman called Rishabh Pant. So in that particular match, Rishabh Pant got one of his teammates run out. Because he got his teammate run out, Rishabh Pant got angry. And because he got angry, he started hitting every ball for a 6. He hit 127 runs that match, but unfortunately, Delhi lost the match when Sunrisers chased the total. But Rishabh Pant is just hitting everything. And then even Bhuvnesh Kumar, who's like the best bowler in the Indian team at that moment, could not stop this fellow Rishabh Pant from hitting. So, and you know what Rishabh Pant was doing? When they were bowling a ball, he was hitting it like this. He was hitting it behind for a 6. Now, what did Siddharth Kaul do? So, Rishabh Pant was hitting all the balls behind, right? Because he's hitting all the balls behind, they kept a fielder behind. Third man, they kept a fielder there because he's hitting everything there. And what Rishabh Pant does is he removes that fielder. He was hitting every ball there for a 6. And there's a fielder. Now, what Rishabh Pant does is he removes that fielder. So, if you're Rishabh Pant, Siddharth Kaul removes that fielder. If you're Rishabh Pant, what would you do? What would you think? Where do you think the ball is coming? Would the ball come at the side to you this way? What happens if the bowler bowled the ball at the side to you?
No.
You'd easily hit it for a 6 and there's no
Yeah.
4. You'll at least get a 4. So if
Right.
you're Rishabh Pant, are you expecting that bouncer? No, right?
No.
And what did Siddharth Kaul do? He bowled that bouncer. You guys get it? He
Mm.
removed that fielder. That's a risk he's taking, right? Because if
Right.
he hits it there, it's a 4 or a 6. And he bowls it there. But Rishabh Pant thought it's not going to be a short ball. It's going to be a full pitch ball. He was trying to hit it on the front foot. He didn't go on the back foot. Dot ball. Next ball. Again, the fielder is not removed. If you're Rishabh Pant, would you expect that he's going to do it again?
Yeah. Maybe.
I mean, is he going to bluff you again?
No.
And the
No
second
chance.
play he did it again.
Yeah.
And Rishabh Pant didn't expect it. Rishabh Pant got fooled not once but twice. And then he was laughing that he just got fooled. You see that as a fantastic mind game.
Yeah.
I'll tell you something which I tried in a street cricket match. We used to play in IMSC Research Institute. We didn't have a cricket ground, so we used to play inside a tennis court. So what we did was, I removed all the fielders on the leg side and I kept all the fielders on the offside. Now, what does the batsman try to do? I removed everybody on the leg side and kept everybody on the offside. So what will the batsman try to do?
Hit towards the leg side.
Like,
And what is the stronger side usually for street cricketers?
yeah, let's say.
Leg side.
Leg side.
Proper cricket knowledge needs practice. So I gave them the strength zone. And I bowled every ball outside off stump, out swinger. They're trying to hit an out swinger outside the off stump on the leg side. What happened? Tough.
It's hard. Yeah. It's hard to pull.
That too, I was bowling the good length. The good length, which it's like it's coming at your ribs height, to hit that leg side is tough. You need a lot of, when you need that absolute timing and you need to pull it with class to get it there. They could not get it going. So if you were that batsman, what would you do?
I tried to hit on the offside one.
Exactly, find a gap and still hit it, right?
Yeah.
Try to clear it on the offside only. There's no other way. You'll have to wait for me to bowl it too short that can go and smash it on the leg side. Or wait for me to give you a full toss so you can score it as a 6 or something like that. You'll have to wait.
On the shape.
You see, again, that's tactics, right? You know your moves, you know the moves of the other person, and you know what is going to happen. And when you use these tactics, so it's like, see, when you study game theory, right? What happens is your entire thought process changes because you're always thinking of what are my choices, which choice is better, how is that other fellow going to think, how do I make my moves so that the other fellow, how do I make my moves while planning for the other person's moves? Does that make sense?
Oh, just come again.
I was saying that how do I make my moves while planning for the other person's moves?
Right.
How this person is going to move. Like if let's say I'm going in a class, exactly like chess. Let's say I'm in a
You are
class,
anticipating the next opponent's move.
exactly. Not just anticipating moves, but you're trying to see.
Prepared for that.
Exactly. You're preparing and you're optimizing your moves at every second. Like how chess players optimize. So game theory can give you that outlook of business. I mean, game theory is extensively used in business, sports, politics, economics, right? And evolutionary biology. Okay. Now let's see an interesting game called Prisoner's Dilemma. So Prisoner's Dilemma is one of the classic games. So in Prisoner's Dilemma, what happens is, let's say Tushar caught two thieves at a crime scene. Okay. And Tushar has enough evidence that they were possessing weapons at the crime scene. But Tushar does not have evidence that these guys committed the murder. You get the game, right? Tushar doesn't have evidence that they did the crime, but Tushar has evidence that they had weapons at the crime scene. But he needs these guys to confess. If any one of them confesses, he can send them to jail and he can make sure they get punished. So what Tushar does is, he takes one thief to one prison and the other thief to another prison, and he tries to play a game with them. He says, if you are, say, goes and tells person one, if you confess, I will let you go free. If you don't confess and the other person doesn't confess, I anyway have evidence that you were possessing weapons at the crime scene, you will go to jail for 1 year. If both of you don't confess, I anyway have evidence that you are possessing weapons at the crime scene. So I can send you to jail for 1 year. Now, if you don't confess and the other person confess, you're dead, I'll send you to jail for 5 years.
So we are like fishing. You are giving him something to grab.
Exactly. So it's like this person, you confess, the other person doesn't confess. That fellow will go to jail for 5 years, you will go free. The opposite, you don't confess, the other guy confess, you'll go to jail for 5 years.
Sure.
But both of you stay united and both of you don't confess. I at least have evidence that you guys were carrying weapons at the crime scene. I'll send you to jail for 1 year. Then the prisoner asks, what if both of us confess? Like, beautiful, both of you go to jail for 3 years. Right. Now, let's see the game. Both the players. So player A will either confess or not confess. Confess or not confess. So if this player A confesses, both of them confess, both go to jail for 3 years. Now this guy confesses, the other guy doesn't confess. This guy goes home and this guy goes to jail for 5 years. And this is the opposite, right? He doesn't confess, he goes to jail for 5 years. The other guy goes home. Both of them don't confess, they go to jail for 1 year. Now, you think from this guy's point of view, if he confesses, if the other guy doesn't confess, what is better for you, to confess or to not confess? If the other guy doesn't confess,
Confess.
what is better for you?
Better to confess.
Why? Because then
Yeah.
There he is.
you go home.
Yes.
Now, if you confess, if the other guy confesses, what are you better off doing?
Confessing itself, you can reduce 5 to 3.
Exactly.
Confess it.
Now, for both of them, the better strategy is to confess. So both of them would confess. So the equilibrium, people tend to think that confessing is a better thing. But in reality, if they both had the trust in each other and they would not confess, they would get jail for just 1 year, right?
Yeah.
Yeah.
Now, this prisoner's dilemma has an equivalent when there are multiple players and that's called tragedy of the commons. Tragedy of the commons is, now let's say there's a big grazing area. There's a very big grazing area and you can come and get cows to graze. Now Yash comes and gets 2 cows, Pratik gets 2 cows, Tushar gets 2 cows, everybody gets 2 cows. Now Hari is like, wait, I'll get 5 more cows. Hari gets 7 cows. Because he's like, if I get more cows, I can get, I can take in more, more free grass and, I can make more money. But they all contribute the same amount of money. Now by seeing Hari get 5 extra cows, Ganesh gets 10 extra cows. Now all the grass is going away. The grass is going to take much more time to grow. Is Hari concerned about what will happen if the grass doesn't grow? I'll care what's in it for me. How will I optimize for myself? Now everyone thinks what's in it for them. Eventually what happens? The equilibrium is everyone increases their consumption. But eventually the whole ground is gone. Now we can take the same tragedy of the commons in Diwali context. Let's say during Diwali, Ganesh blasts 1 cracker, Yash blasts 1 cracker, Omkar blasts 1 cracker. Everyone is blasting 1 cracker. Now suddenly Tushar is like, if I blast 2 extra crackers, how much of a difference is it going to make to the environment? Then Ganesh is like, if I blast 3 crackers, how much difference are my 3 crackers going to make to the environment? Now all the 140 crore Indians decide, let me blast 5 crackers, what difference is it going to make to the environment? So 700 crackers makes a difference to the environment.
Yeah.
So the game at each player's level is like, my 1 cracker, what difference does it make? Now, if you don't blast the cracker, what happens? You feel like you've lost an opportunity, right? I've lost that.
Right.
Just like the prisoner's dilemma. If I don't confess, I'm screwed. But if all of us together stayed united and didn't confess, we would have got a better payoff. It needed trust. In tragedy of the commons as well, if all of us decided we'll not blast crackers and nobody does, that's a better situation for all of us. But what is happening is the equilibrium tends to be the case where people are like, no, I'll think of what's in it for me. So tragedy of the commons, you can look at it as a multiplayer version of the prisoner's dilemma. So this is why game theory is very useful in a social context as well. So when I was in ICER, I did one research project. So there what we did is in prisoner's dilemma, right? We created a new player. And prisoner's dilemma, we created a new player called Punisher. So what that Punisher would do is, if you don't cooperate, if you confess, you don't cooperate, the Punisher will punish you. So when we included these new players called Punishers, the cooperation went up. But what is happening is that for the Punisher to punish, the Punisher has to bear a cost to punish. The Punisher started dying. Then we created a new kind of a Punisher called discriminating. I'll not go into technical details, but we added a new player. So then when we had 4 different kinds of players in the society, we saw more cooperation. We ran a simulation to understand what is better for the society. So game theory can be used to understand how people behave and why people behave the way they behave and so on. And it's interesting because it changes how you look at things. Now, when it comes to soccer, so there's something called Minimax theorem. So do you kick towards the left or do you kick towards the right? So that's the decision, right? So now let's say there's a probability distribution. With half probability, you'll kick left, and with half probability, you kick right. Now, as a goalkeeper as well, you need a probability distribution, right? With what probability you go left and with what probability you go right. So they took the data of different games to see, what is the probability of, the scoring a goal if you kick left, and what's the probability of scoring a goal if you kick right? What's the probability of saving a goal if you move left, and what's the probability of saving a goal if the goalkeeper moves right? And then they used game theory to calculate. There's something called Minimax theorem. Using Minimax theorem, you can find out a kind of an equilibrium. And it turns out that world's best professional goalkeepers actually follow this to save the goals. what probability the professional goalkeepers were using actually matched with the probability which was theoretically calculated using this data. And if you're interested, you can read this research paper called Professionals Play Minimax. In that research paper, this is explained. Theoretically, they were able to calculate how to move left or to move right in soccer. So this concludes what I wanted to convey. I'm happy to take probably this time for 3 questions.
Yeah, actually, Tarun, this game theorem, how can we, apply this in a very fast-moving business environment? Is there a small example that you can tell? Since
Absolutely.
it's very, very dynamic, right? Business environment keeps changing like on a minute-to-minute basis. So how can we anticipate someone's move and be prepared for that?
So yeah, so I think Hari Krishnan, while it is very difficult to model everything that is happening in the business environment, I think the core of a business, right, the core game, while the micro details change every day, the macro core remains intact, right? Like in terms of if you're selling a bottle of coconut water, and if there's a customer, does the customer prefer that bottle of coconut water, or does that customer prefer a bottle of thumbs up? Now that's a game which remains invariant across conditions, right? So you try to make a simplistic model of the situations which recur a lot, and then study that model to figure out how do you want to design the game so that people come back to you again and again. For example, let's say you're designing prices. You have platinum, gold, and silver pricing. Your consumers are more likely to pick up the middle one.
Yeah.
So that pricing model is something which, probably doesn't change too much. So these kind of core scenarios, you can make a model, and through that model, you can decide, what move works best, what move doesn't work best. I agree with you that things are too dynamic, and to model things which are too dynamic is very challenging. But we try to identify the critical pieces and we model that and study that. Yeah. Happy to take the next question.
I have a doubt. So I'm actually writing a technical paper on the relationship between game theory and engineering. So I was talking especially regarding the computer network. So when a host or a server sends a packet to the user, you'll have a lot of like many factors being involved over there. So there is a high chance that there will be loss of information in the packet. So I wanted to use game theory to understand in what way we can send the packet so that there will be no loss of information. So my question over here is one, can game theory be actually used in engineering? I mean, in the technicality and stuff. And 2, is my thought process right when I'm talking about exchange of data and its involvement in game theory?
Game theory is extensively used in computer science because every game has an algorithm to solve that game, and every algorithm has a game. To analyze every algorithm, you can play a game. So it's like the game between you and God. Let's just say you believe in God. It's like, so every algorithm is like a game between you and God. So God gives you the bad scenario, and you are trying to test your algorithm against that bad scenario and see how well your algorithm does. So there is that interconnection between computer science and game theory. So that's to answer your first question, key, is it used in engineering? Now, when you want to study these networks and all of that, if at all in that networks, there are moves to be made, there are choices to be made, and based on those choices, the results are going to be affected. Again, you can use game theory to see, okay, what are the choices for this player? What are the choices for this player? And based on the choices, how are the outcomes going to be affected? How would this player behave and how would that player behave, and what is best for the whole system? That kind of investigation, again, you can use game theory, provided there are players and those players can make choices. So provided your client can make choices and your server can make choices, that's when game theory can come in. But if your client cannot make choices and it's just at random, then probably it's not game theory, right? Game theory is when those moves are made available to me and then I move. Now, let's say I'm a prisoner and I'm not choosing whether to confess or not confess. I'm randomly doing it. I'm not given a choice. Somebody else is controlling me, hypnotizing me and telling. Then game theory is not going to be too helpful, right? Because if I am allowed to make the choice, I can reason and figure out what is correct for me. Or even if you say it's at random, we can probably still use game theory to understand if this if this happens here and if this happens here, what is going to happen? How would we want this? How would we want the client to behave? How would we want the server to behave? What kind of behavior of these two together is going to make the system in a better way? So probably you could analyze it that way. Did I answer your question?
Yes, you answered. Got it.
Go back to the fundamentals, right, Ganesh?
Yes.
This player, moves of this player, what are the implications of each combination of moves?
Done. Got it.
Yeah, Pratik.
Yeah, and you said that it has an application in biology also. Like, if you can elaborate on that.
Sure. So
Game theory. Yeah.
there is something called they've used this extensively to study guppy fishes. There's one experiment I read where so I think there's evolutionary game theory. In evolutionary game theory, you try to understand how these see, basically, if you understand evolution, right, those animals which so there's a genotype and a phenotype, right? So due to mutations, certain genotypes are expressed, and that genotype expresses itself in a certain phenotype, and that brings out so there's a tall giraffe or a short giraffe and so on. So the genetic differences can lead to physical differences. Now the height can influence the survival rate of the giraffe. Whatever accident is happening, whatever variation is happening, that variation, some of those variations can give an advantage of survival to some of the animals. So in a way, you can use game theory to understand, evolutionary game theory to understand what kind of mutations can be favorable and so on. So you can use game theory to understand what would be better for that animal and so on. So if you read this book called Selfish Gene by Richard Dawkins, that gives a very good explanation of evolutionary game theory.
Right. So basically, I mean, if you can, if we have to see anywhere the game theory, it's the basic prerequisite is that someone has a choice to be made. Then only.
The gene has a choice how to get expressed and what to come.
Right. Okay. Yeah.
You're seeing how the genes are going to get expressed in the.
Yeah. Right.
So what kind of mutations can come out? What is better for the species and so on?
Yes.
Yeah, Tushar.
Initially, you talked about reverse game theory as well, right? Can you give an example of that as well?
Reverse game theory as in mechanism design. So mechanism design, let's say you have something called demonetization. So demonetization is a game you have designed where you say, hey, your 500 rupee notes and your 1000 rupee notes are not going to be valid anymore. If you guys are aware, 2016 demonetization happened 7 years back. So suddenly the 500 and 1000 rupee notes were demonetized. So then by you designing this game this way, you're changing the behavior of the people. That is, people not, holding on to black money or money which is unaccounted by the system. Or so people are now going to try and account for all that money. Earlier, you didn't know how much cash was in circulation in the country. Now you know how much cash is in circulation in the country. Earlier, people wouldn't tell you that they had so much of cash. So you wouldn't know how much cash you have. But now people are telling you how much cash they have, because that 500 and 1000 will be gone if they didn't, come and hand it over to you. So that's an example. Or let us say you're a class, you're designing an exam paper. How many marks you give for each thing? That changes what the student is going to be doing, right? Let's say for an assignment, you're given some marks, you start putting more effort into doing that assignment properly. So that's an example of mechanism design there. How do you design?
Tarun, I have a small doubt. Since you have mentioned about demonetization, and UPI is one of the biggest success in the past years. So do you think it's one of the game theory, strategies by government so that people won't hold on to cash, lot of cash, like trigger point?
So I think, Hari, you can use game theoretic analysis to understand that. So if I, as a player, I have to create my own infrastructure to do it, I may not be willing to do it. But if the government has created the infrastructure and given, maybe all the players would want to do it, and that does increase the digital payments in the country. If you see it from a game theoretic perspective, right? Why would Hari Krishnan want to create that infrastructure? Why would Rohit want to create that infrastructure? But if the government is already creating and giving you that infrastructure, you don't mind using it, right? So every bank is giving that UPI option to the customers because the government has set up that infrastructure already. So people are able to use it extensively. But if the onus was on the bank to make that thing possible, the bank would incur a cost due to that. So the bank would not give it for free. The bank would say, I'm incurring a cost, I will not give it to you for free. I'll charge you 10 rupees per transaction and all. The
So
customer,
do you think demonetization kind of pushed people into UPI, kind of began that momentum?
I don't have enough facts. But what I'm saying is I don't have enough facts to answer your question. I don't know the chronology of when demonetization UPI and all of that. But what I'm saying is when it comes to UPI, right, an interesting game you can observe is if Ganesh is a bank and Ganesh says for every UPI transaction, I'll charge you 20 rupees. And Omkar is a customer. Omkar might say, I will not use UPI because you're charging me 20 rupees. But if the government can make that infrastructure possible and say, okay, you're supposed to give this UPI for free. The bank doesn't mind giving it for free. And Ganesh is like, okay, fine, I will use UPI only because I don't have to pay any money. So now when when these transactions are, zero cost transactions, you're cutting down on the amount of cash in the country. And that's also helping you have better tax collection, right? Because when everything is happening, you know how much, you can tax and,
Correct.
income tax department to some AI to, reduce tax evasion.
Yeah.
So I understand this was a very interesting topic, but I'll have
So
to.
game theory is that once I listen to game theory, I kind of see the similarity in a lot of places.
Yeah. So in case you guys find this interesting, you may read this book, Selfish Gene by Richard Dawkins. And and there are ample videos on YouTube as well. And there are a lot of there's also a course on game theory by Yale University, which is available for free on YouTube. You guys may want to do that course in case you find it interesting. These are some pointers I can give you. Rock, Paper, Scissors is one book on game theory. And there's very interesting. Game theory is used in psychology as well. If you're interested in psychological analysis of game theory, there's this book called Games Indians Play by V. Raghunathan. He explains Indian behavior using game theory in that book, Games Indians Play. So these are some pointers for you. Thanks a lot for joining. And the workshop, which I'm very excited about, is the next one, which will start at 7:30. For the lack of a better word, I'm calling it Business Anthology. 10 short stories of business to show you how beautiful the world of business is. 10 very beautiful stories of business is what I'll be covering in this Business Anthology at 7:30. Those who are interested can join in. Thank you for joining.